Welcome to Brainthropology. This portion of our podcast is about mindfulness meditation. And we believe it is important to practice mindfulness every day. I'm really honored that you're here joining us in this podcast today. Thanks. Hello, and welcome to the second part of the podcast. Today, I'm going to talk to you first, before we meditate, about the impact of stress on our brain. I'm going to talk about various structures in the brain and how they're influenced by stress. So, what do I mean by stress? In the research literature, stress is referred to as activation or arousal, and we just call it being stressed or feeling stressed out. We recognize that there are internal and external reactions to stress. For example, the autonomic nervous system comes into play, meaning that we could be hyped up or we could become disengaged. We will release assorted stress hormones, and perhaps we engage in behaviors to distract us from the stress, like eating or shopping or procrastinating or unnecessary cleaning. When a significant stressful event occurs, the brain sends signals to the body. And this is with a significant stress. The body can go into fight, flight, or freeze-submit mode, shutting down or slowing down non-essential systems like digestive, immune systems, reproduction, growth, peripheral blood flow, and increasing heart rate, blood pressure, breathing rate, muscle tension, and metabolism. Clotting factors are released as well. So, call to mind any times when you've been under stress and you've noticed some of these responses, like a car accident or an intense argument or a difficult work situation. Call to mind times when you've noticed a response that your body or your behavior has to stress. What did you notice in your body when a stressor occurred? Where? Did your body feel hot or cold, tight, tense, hard? Did you have any nausea or stomach upset? Sometimes it's not even clear. Do we even notice these physical sensations when we're under stress, or are we only aware of that afterwards? It's also interesting there are social expectations about acknowledging reactions to stress, like it's not okay to express our distress, or maybe making a joke of it, or otherwise withdrawing. In a single smaller acute stress response, all these changes I mentioned before occur, and then when the stressor is gone, the body returns to normal fairly quickly. The kind of stress I'm talking about, is when stressors are severe or chronic and persistent. The body stays out of balance and tends to get stuck, no longer functioning normally. We create worn-out neural pathways. The body, if it's under severe or chronic stress, including the neural system, is less likely to return to normal. The brain itself actually changes when one is chronically stressed. Various structures become larger or smaller depending on the stress. The brain is a living organism. It's dynamic. The experiences that it has can shrink it or enlarge it. It's considered to be neuroplastic, meaning that throughout our lives, it can continue to form new neural pathways, meaning healing of some sort is possible. Again, I want to repeat that high stress or trauma shapes the brain. It changes the brain. And stress itself produces a chain reaction in the brain, like all the dominoes falling over. The brain's response to stress activates several parts of the brain. So today we're going to look at some structures in the brain and how they're affected by stress. The stress response cascade begins in the brain when someone confronts something dangerous, like an oncoming car or a giant spider or some other danger. The eyes or ears or both send information to the amygdala. The amygdala is in the mid-center of the brain, and it's a subcortical structure. It's also referred to sometimes as the fear center. Now, when a structure is subcortical, it means that it's outside of conscious control and conscious awareness. The amygdala is nonetheless quite powerful. It's referred to as the, quote, smoke alarm, end quote, because the amygdala's main job is to detect danger or threat. If the amygdala senses that a situation is threatening, it activates. The greater the threat, the higher the activation. When this activation occurs, the amygdala begins to shut down the function of higher thinking areas in the brain, the areas for rational thought and emotional regulation. It activates the stress pathway, the hypothalamic pituitary adrenal axis, as well as the stress response in the body. This involves the sympathetic nervous system, which we discussed in the window of response session. The sympathetic nervous system is the accelerator. Another thing about fear is that it can become generalized, meaning if a person was attacked by a dog, then they can become afraid of all dogs. We know that those individuals with high stress or post-traumatic syndrome often have a hyperactivated amygdala. In the treatment of trauma, we attempt to reduce activation of this area of the brain. Deactivation of this area can reduce the stress response and reactivity to trauma triggers. The next structure I want to talk about is the hippocampus. It's considered to be, one, the memory center of the brain, and it's also referred to as, two, the timekeeper. The hippocampus is the main brain structure that stores memories that you can consciously access. Take a moment to remember a pleasant memory. Maybe it was something you ate or the sound of a bird singing. Because you can remember a pleasant memory, that's because of the hippocampus. Just like the amygdala and other brain structures, it can change size when stressed. There was a study done in London of several brand new taxi drivers, and they did imaging studies of the hippocampus. And then they followed up 5 years later, after these taxi cab drivers had a lot of experience with learning the map of London. And they found when they did imaging this time that the amygdala, that the hippocampus had increased in size. During times of intense stress or trauma, the memory center becomes underactivated. It can even shrink, resulting in memory-related difficulties. This is why eyewitness testimony is so controversial, as memories created during high stress can be distorted or not even stored at all. When the hippocampus becomes underactivated, it can provide inaccurate information to the amygdala. The amygdala, in communicating with the hippocampus, the amygdala asks the hippocampus, has this situation been dangerous in the past? the underactive hippocampus may respond incorrectly, informing the amygdala that it is a harmless situation, even when it's actually dangerous. A person experiences flashbacks because a past memory is experienced as being in the present. And that's because when the hippocampus was under stress, it forgot to put the time stamp on the memory. This is why people have flashbacks. Increased activation of the memory center can help people to feel that they are safe, and it decreases fear responses when trauma triggers are present. The next structure I would like to introduce you to is the insula, and that is the interoception center. It allows you to be aware of and to connect with internal sensations and experiences. So, an example of interoception is when you know you are feeling hungry, when you know you're feeling warm or restless. Without a strong and regulated insula, it is very difficult to identify physical sensations as well as emotions. When you are able to feel the body and connect with internal sensations, you can identify emotions, because those body sensations that you recognize can give vital information about the emotion you're experiencing. It also differentiates emotions. For example, you're able to distinguish how the feelings you have for your child are vastly different from anger towards your boss. With trauma, the insula is often dysregulated. It may be underactive, hyperactive, or hyperreactive to sensations. If a person has a regulated insula, they have less emotional outbursts and less dissociative or numbing symptoms. A person is able to feel their own body and identify the emotions they are experiencing as well as regulate them. The next structure is the prefrontal cortex, sometimes referred to as PFC. This is the thinking center, and it's associated with our unique human abilities. This is a large region with many smaller structures. The outer lateral areas of the PFC are involved in higher order thinking, like decision making, concentration, awareness of others, empathy, social intelligence, and just executive functioning in general. The center areas of the PFC are involved in self-awareness, self-regulation, and personality. Although theoretically we could survive without the PFC, we could not function well or have close relationships. In a traumatized brain, the PFC becomes underactive. When that happens, the person has difficulty concentrating, making decisions, connecting with others, and being self-aware. A person cannot reason during stressful situations. If the PFC is properly activated, one experiences clearer thinking, improved attention, a sense of connectedness to others, and increased self-awareness. The cingulate is called the self-regulation center, and it's a cortical area of the brain that regulates emotions and thoughts. Have you ever had the experience of waking up from a dream thinking that what you dreamed was real? I once dreamt that my neighbor girlfriend across the street had done something with my boyfriend, and I woke up angry because I thought it was real. So when the cingulate's functioning correctly, in a few moments after you wake up, you would say to yourself, oh, that was just a dream. It was not real, so I don't need to be angry. In order to stop feeling angry about the dream, the cingulate or self-regulation center needs to be activated. The cingulate is a master control center. All these structures are interconnected. For example, the cingulate will try to quiet the fear center or the amygdala. It will try to collaborate with the PFC to enhance decision-making and functioning. When we practice meditation, the PFC and the cingulate cortex interact. The PFC allows you to focus on your breath or a thought, and the cingulate cortex alerts the PFC when your mind wanders. This area of the brain is activated when we are trying to work out conflicting thoughts. You may feel both love and anger towards your mother, for instance. In the traumatized brain, the person has difficulty with emotional regulation, thought regulation, and decision-making. Increasing activation in this area improves the ability to regulate unhelpful or painful emotions and to manage distressful thoughts. We know that there are accompanying physical changes with stress. The fight or flight response is responsible for the outward physical reactions most people associate with stress, including increased heart rate, heightened senses, a deeper intake of oxygen, and a rush of adrenaline. Finally, in the stress cascade, a hormone called cortisol is released, which helps to restore the energy lost in the response. When the stressful event is over, cortisol levels tend to fall back to normal, and the body returns to stasis. Nobody can avoid stress. Stress is necessary. But while stress itself is not necessarily problematic, the buildup of cortisol in the brain can have long-term effects. Thus, chronic stress can lead to significant health problems. Cortisol's functions are part of the natural process of the body. In moderation, the hormone is perfectly normal and healthy. But when chronic stress is experienced, the body makes more cortisol than it has a chance to release. This is when cortisol and stress can lead to trouble. High levels of cortisol can wear down the brain's ability to function properly. According to multiple studies, chronic stress impairs brain function in multiple ways. It can disrupt synapse regulation, resulting in the loss of sociability and the avoidance of interactions with others. Stress can actually kill brain cells and even reduce the size of the brain. Chronic stress has a shrinking effect on the prefrontal cortex, that area of the brain responsible for higher order thinking. Christopher Berglund in Psychology Today wrote, cortisol is believed to create a domino effect that hardwires pathways between the hippocampus and the amygdala in a way that might create a vicious cycle by creating a brain that becomes predisposed to be in a constant state of fight or flight. Plasticity or neuroplasticity refers to the ways that neural pathways are able to reform in the brain. It's true that these pathways can get severely damaged due to constant exposure to stress, but such changes are not necessarily permanent. While stress can negatively affect the brain and the body can recover. Research shows that positive thoughts decrease cortisol and produce serotonin. And serotonin creates a sense of well-being and helps the brain to function at peak capacity. It's part of mindfulness practice. Even when we have negative thoughts arise, we can use positive self-talk to help us remember our true value. The reality is, all thoughts need attention to grow, just like a plant in a garden. So while we may have both difficult and positive thoughts at the same time, we can use mindfulness to focus on the positive more than the negative. So that was the end of my discussion on brain structures and how they're affected by stress. Let's do a short meditation now, focusing on the breath. So I will sound the bowl once to start the meditation and 3 times to end the meditation. Bring your attention to your posture. Be aware of yourself sitting and make your posture symmetrical. Let the weight be even on the right and left sides of the body. You can elongate your spine. Let your shoulders relax. And now focus on your breath. The breath coming in and the breath going out. Just be aware of the breath where you most easily feel it, perhaps at the nostrils, perhaps in the torso, perhaps in the lower belly. And let's take 3 deep, full inhalations and exhalations. Do this on your own timing. Notice the power of the breath to bring calmness both to the body and the mind. Bring to mind a recent stressful event that you had, or perhaps one that's coming up in the near future. And once you have this stressful event clearly in your mind, observe your mood. Try to do so as if you were watching yourself, as if you were witnessing your emotions rather than being swayed by them. When a thought, a physical sensation, or an emotion emerges, pause. Allow it to be. Observe it and name it. So if you're recalling a stressful argument, you might name that thought or label it as anger, anger. If you're criticizing yourself for something you did, you might say, judging, judging. Or let's say you're recalling a sunset. You might say memory or quiet joy. But allow that thought or that physical sensation or that emotion to be there. Recognize it, name it, and then let it drift off. After that, return to your breath. The breath is always in the present moment. Let the air go in and out through your nostrils if you can. Or if you can't, just breathe as you customarily do. The nostrils filter the air better than the mouth. Let yourself become completely still. Focus on the thin stream of air coming in and going out. Coming in and going out. Think of the breath as caressing you as it enters and leaves. Notice how this touch of the breath impacts you. In a few moments, I will sound the bell. Let yourself carry calmness with you as you go on about your day. When the sound of the bowl has faded away, slowly open your eyes and you may wish to move your fingers or toes. That concludes today's meditation portion of the podcast. Thank you so much for joining, and I look forward to seeing you next time. Thank you.